everyone. Today we are going to discuss about the project in data science. Topic is SVM, support vector machine image classification, cats versus dogs. Okay, so first we need to understand what is support vector machine. A support vector machine is a supervised machine learning algorithm used for classification and regression tasks. Its main goal is to find the best boundary called a hyperplane that separates different classes of data. In simple terms, imagine you have cats and dogs plotted on a graph. SVM tries to draw a line that separates them as clearly as possible. What makes SVM powerful is that it doesn't just draw any line, it chooses the one with the maximum margin, meaning the distance between the nearest points called support vectors of each class is as wide as possible. This helps the model generalize better on unseen data. Okay, so let's first start from importing the libraries. Here import pandas spd, import matplotlib.pyplot from sklearn.model selection, import train split from sklearn.svm, import as svc from sklearn.matrix, import accuracy score. Okay, so in the first part of the code we import the important Python libraries required for data handling, visualization, and machine learning. Pandas is used to load the data and manipulate the data sets, while matplotlib.pyplot helps in visualizing the data. From sklearn, we import train trace split to divide the data set into training and testing sets, SVC to build the SVM model, and accuracy score to evaluate how well the model performs. This library is from the foundation of the entire machine learning workflow. After that, we load the data set. Okay. So here df equal to pd dot read excel cats doc svm dataset dot xlsx. Okay. So simply the dataset loaded using the this code, and this line reads an excel file containing the data of cats and dogs. Each row represents a data point, and the data set includes features, feature 1, feature 2, along with a target label that indicates whether the data point belongs to a cat or a dog. Loading the dataset correctly is crucial because the model depends entirely on this data for learning patterns. Okay. So after that there is features and targets. So x equal to df feature 1, feature 2, y equal to df label. Okay, so here after loading the dataset, the code separates the input features and the target variable. Okay, x contains the independent variables which are used by the model to learn patterns. Y contains the dependent variable which represents the actual category cat or dog. This separation is important because machine learning models learn relationships between input features and the output level. Okay, after that, train test split. So in train test split, x train x test, y train y test equal to train test split x y test size equal to 0.2. So the data set is then divided into training and testing sets using train test split. Here 80% of the data is used for training the model and 20% is used for testing. This step ensures that we evaluate the model on unseen data, which gives a realistic measure of its performance. Without this step, the model might simply memorize the data instead of learning meaningful pattern. Okay. After that, train SVM model. So as you can see here, model equal to SVC kernel equal to linear model dot fit x train y train. Okay, so in this step the SVM model is created using SVC kernel equal to linear. The linear kernel means the model will try to separate the data using a straight line. The model dot fit x train y train line trains the model using the training data. During this process, the algorithm identifies the best boundary that separates cats and dogs based on the given features. Okay, after that we come to make the predictions. So here ypred equal to model dot predict x test. Okay, so once the model is trained, it is used to make predictions on the test dataset using model.predictXtest. This step applies the learned patterns to new unseen data and predicts whether each data point belongs to a cat or a dog. Okay, after that we need to evaluating the model accuracy. So print accuracy score y test y pred. Okay, so the model's performance is evaluated using accuracy score, which is y test y pred. This metric calculates the percentage of correct predictions made by the model. A higher accuracy indicates that the model is performing well in distinguishing between cats and dogs. Okay, after we come to data visualization. So as you can see here, plt dot scatter x feature 1, x feature 2, c equal to y, c map pool bound, plt label, plt dot x label feature 1, plt dot y label feature 2, plt dot title cats versus dog classification, plt dot show. Okay, so this is a scatter plot as you can see here. So finally, the code visualizes the dataset using a scatter plot. Each point represents a data sample and colors indicate whether it is a cat or a dog. The plot helps in understanding how the data is distributed and how well the classes are separated. In data visualization, finally the code visualizes the dataset using a scatter plot. Each point represents a data sample and colors indicate whether it is a cat or a dog. The plot helps in understanding how the data is distributed and how well the classes are separated. Okay, as you can see here, uh, it shows a clear spatial separation between two classes. Okay, labeled as blue and red data points based on feature 1 and feature 2. The blue points dominate the lower left region where feature 1 is low, while the red point occupy the upper and right portions where both features tend to have higher values. Because the boundary between the two clusters is curved uh, rather than straight, a non-linear classification algorithm would be required to accurately separate the cats from the dogs. Okay, so if we talk about business problem and solution, so in a real world business scenario, this type of model can be used in applications like automated image classification systems for a pet adoption platforms, veterinary services, or e-commerce websites selling pet products. The business problem is to automatically identify whether an image or data input represents a cat or a dog without manual effort, which saves time and reduces human error. The solution is to use a machine learning model like SVM to classify the data efficiently. By training the model on labeled data, the system can automatically predict the category of new inputs with good accuracy. This improves operational efficiency, enhances user experience, and enables businesses to scale their services without increasing manual workload. Thank you.